augmented, right? It's not replaced. Right. That's what you're referring to? Yeah, right. Yeah. Would you like to dive deeper into industry applications or just talk about general business directions where each business can take advantage, like low-hanging fruit in what technology has to offer?
Yes, why don't we deal with both, I think, at the same time? I think that's very important. So essentially, if we come back to looking at the areas of machine learning and deep learning that have been particularly successful, we tend to find things like, for example, boosting algorithms, and the types of those tend to be things known as XGBoost, light gradient boosting that came from Microsoft a few years ago, and CatBoost, which came from Yandex of Russia a few years ago as well. Tend to be very good with things like tabular data and making sense of those or actionable insights from those. Deep learning tends to really excel with areas such as computer vision, where convolutional neural networks have had large amounts of success on training sets and then performing on things like medical imaging and, for example, fashion object detection and classification, and then recommending similar items for fashion, etc., would be one example. So visual search, detecting object detection to detect an intruder, for example, on a security camera. Navigation for an autonomous vehicle would use a CNN typically. And then it's been areas like neural translation, where we've had the transformers and attention mechanisms of the last few years, and in particular of the last year rather, have a big impact, of which one of the headlines recently has been on GPT-3, which has been trained on 175 billion parameters. So that's a huge, vast machine learning model. And it's been crawling the internet, things like Wikipedia, etc., to learn. And it's a NLP, natural language processing, or NLG, natural language generation model. So it's been a real step forward in NLU, natural language understanding, because for a while NLP, this area of NLP and NLG had kind of lagged behind computer vision. Like if you went back 3 or 4 years ago, a lot of the surge, if you like, in AI and deep learning was happening on CNNs, convolutional neural networks, and computer vision. And now we're seeing rapid advancement in the field of language with transformers. It's a complex mechanism. I won't go too much into detail, but it uses a network of multiple encoders and decoders with something known as self-attention mechanism, and where it's been very effective and had an advantage over techniques such as the recurrent neural networks and LSTMs that were used previously, has been, for example, the ability of transformers to focus on very long sequences and the sentences, and therefore through the particular mechanism that's been used with self-attention and the encoder-decoder network to kind of understand get better understanding or better language translation that had been previously possible before. It is not, however, artificial general intelligence. It is a big advancement in AI. It is a big advancement in the field of natural language and NLP for AI. But it is not. It does not mean that you have to quake in your boots that tomorrow Skynet is going to come and wipe you out.
No, not yet, not yet. So AI is not gonna write our music from now on. It's not gonna create movies for us. It's not gonna do our work for us and continue our presence in this world. I mean, I know it's very vulgar what I'm saying right now, Imtiaz, but it will be great to hear from you. How do you comment on the big news of the new promise?
We have been seeing things like, I don't have the actual statistics, but we do see increased amounts of, for example, with journalism and on the internet, more articles that have been written by bots, if you like. We do
hopefully not too many of them, you know, but yeah, it's definitely a technical, right, capability.
We are seeing encroachments into these areas. We are seeing situations where things like GANs, generative adversarial networks, which is from the field of computer vision that Ian Goodfellow helped create, or inspiring, well, did actually create in 2014. We're seeing these areas with the GANs, which use two deep neural networks which are competing together in a zero-sum game. You have the generator, and it's like two neural networks that are essentially, you have what, I'm trying to think of the best way to describe it. It's been described as the fraudster and the expert.
Mm-hmm.
And the generators creating, if you like, the fake images, or the images which are ultimately fake, really. And you've got the discriminator, which is judging them. And the generator keeps on getting better and better until hopefully it gets to the point where it can fool the discriminator. So imagine it as being the generator being the fraudsters creating the fake banknotes, and the discriminator is the one that knows what the genuine banknote looks like, and they keep on giving criticisms or feedback to the fraudster until the fraudster can actually fool the generator. That's a very simplistic way of describing it. And these techniques potentially, along with CNNs, convolutional neural networks, combined with GANs in the movie industry, in the film industry, maybe we're going to see more synthetic media, as it's called, going forwards, where artificially generated movie sequences may come through. But it is going to take a bit of work yet. There are some who say, for example, in fashion, that we may have artificially generated fashion models in the future. In particular, when we get to 5G and we get augmented reality, mixed reality really take off at that point, and the machine learning continues to advance.